Okay, thanks for tuning in. We are going to talk about chapter 3.4, which is composition of functions and operations. Okay, so this will be probably a review of what you were doing in Algebra 2, and then we're going to add some stuff and focus on domain and range, really. Okay, so let's say I have two functions. Okay, and let's say I have f of x equals x squared plus 2x minus 3, and I have g of x equals x plus 1. Okay, we will find, let's start with addition, f of x plus g of x. So we'll take my f function, so x squared plus 2x minus 3, and we will add to that my g function, x plus 1. Okay, so all we have to do is combine like terms. So x squared plus 3x minus 2. So, and now let's subtract functions. So I have x squared plus 2x minus 3 minus x plus 1. Now note that I put it in parentheses. I really should have been putting all these in parentheses, okay, because we're taking this and we're substituting it in for those variables there. And it's really important on subtraction because you have that negative to distribute. So we'll have x squared plus 2x minus 3 minus x minus 1, which reduces down to x squared plus x minus 4. So then if we do multiplication, okay, we'll take x squared plus 2x minus 3 times x plus 1, and we will FOIL all of these out. Okay, so you can FOIL, you can stack them up and multiply that way, whatever you feel more comfortable with. So we'll have x squared, x to the third, that times that, plus x squared plus 2x squared plus 2x minus 3x minus 3. Okay, so then we'll have x to the third plus 3x squared minus x minus 3. Okay. So here's that one, and now we have division. So f of x over g of x, x squared plus 2x minus 3 over x plus 1. And we're actually going to leave it there for now. Okay, I haven't actually taught you in this course how to do polynomial division, so we're going to leave it there for now. Okay, so this should have been done in Algebra 2. It probably was, but if you don't remember it, that's okay. What I'm adding to it is domain. Okay, we have to understand what x can and cannot be. So in order to do that, okay, anytime we do operations, the domain is the intersection of the function domains. Okay, so the domain of this function of the addition is the domains of these two intersected. Okay, so wherever those two intersect, that's my new domain. Well, if we look at the domain of this one, this is a parabola, so it covers the entire x-axis. So the domain of this part is negative infinity to infinity. Okay. And this one's a line, so it's also negative infinity to infinity. Okay. Think about there's no bad x values in here. Okay. So if I graph out, okay, let's see, here's my number line, there's 0, there's -1, and there's 1. Okay. If I graph out negative infinity to infinity, okay, so this is my first domain, negative infinity to infinity. And this is my second domain, negative infinity to infinity. Where their intersection or where they're overlapping is what I want. Well, they overlap all the way across the graph there. So my domain for this one would be negative infinity to infinity. This one would be minus infinity to infinity. This one would be minus infinity to infinity. Now, division is where we have a problem, okay? Because it is the intersection of the two, but it is also the intersection of where this is not 0. So we have to get rid of that value. So in this case, I have to get rid of -1. So we're at negative infinity to -1, union, -1 to infinity. Okay, and that would be my domain. Okay, so you get the sum function, you got the subtraction, multiplication, a product function, and quotient function. Okay, so we want those intersections or unions. Okay, so that one was pretty basic. So let's try a little bit tougher one. Let's say my new function, g of x, is the square root of 4 minus x. And f of x equals the square root of x minus 1. Now, before we go anywhere, let's just go ahead and find what our domain is of each one of these. So this under here cannot be, has to be positive. So we set it bigger than equal to 0. And so we'll add x. So I get 4 is greater than equal to x. So that tells me negative infinity to 4 would be my domain. For this one, we have x minus 1 has to be bigger than 0. So x has to be bigger than equal to 1. So that goes from 1 to infinity. So let's look at where f of x plus g of x. Okay, so that's radical x minus 1 plus radical 4 minus x. Now I can't combine those at all, so we'll leave it like that. But we need the domain. Now the domain is the intersections of these two. So if I graph these out here, okay, so I'm at 1 to infinity, and I'm at 4 to negative infinity. Those two intersect or overlap right in there. So the domain of this one would be 1 to 4. Okay, that's where the two lines overlap. So then we have f of x minus g of x. So that's radical x minus 1 minus radical 4 minus x. Again, we can't do anything with those, but our domain is 1 to 4. Multiplication, f of x times g of x. That's radical x minus 1 times radical 4 minus x. Now, in this case, we can do these radicals. That's like saying, if I come over here real quick, that's saying like radical 2 times radical 3. Well, I can multiply these two together and get radical 6. That's kind of what we're looking at here. So I'll multiply these two together and get x minus 1, 4 minus x, and I'll have to FOIL that out and distribute it out. So we get the square root, 4x minus x squared minus 4 plus x. So I get the square root of minus x squared plus 5x minus 4. And again, the domain, even though we did some special and some more stuff in there, the domain is still 1 to 4. Okay, so I got f of x over g of x. And we could switch this up. I could put g on top if I wanted. It doesn't matter. So that would be the square root of x minus 1 over the square root of 4 minus x. Okay. Now, we still use this part, but if you notice down here on the denominator, this cannot equal 0. Well, think about it. In this window right here, this 1 to 4, are there any numbers that make this one 0? Yes, 4 would make it 0, so we need to get rid of 4. And I simply do that by putting the parenthesis instead of the bracket. Remember, bracket means I can choose. Parenthesis means I can choose everything up to it, but not including. All right, let's look at this function. Let's say f of g of x equals, let's say it's radical x over x minus 3. And you would have been told that f of x equals radical x and g of x equals absolute value of x minus 3. Okay, so let's go through these two and find out what our domains are of each one of these. Okay, so x has to be bigger than 0. So we'll say 0 to infinity. And here I can have anything. It's an absolute value. That's a v, so it covers the entire x-axis. From negative infinity to infinity. Okay. But we want where they overlap. And if I look at the graph, okay, here's 0, here's 1. Gotta have two numbers on there. So I have negative infinity to infinity. And then I have 0 to infinity. So where do they overlap? They overlap from 0 to infinity. Okay, so that's the base of this. But we also have to look at this denominator and see, okay, what makes that 0? Out of 0 to infinity, is there anything that will make that 0? Yes, 3. So I have 0 to infinity union x cannot equal 3. And we'll rewrite that 0 to 3 union 3 to infinity. And that's our domain. Okay, that's what we want as an answer. Okay. The next thing we are talking about, so that's operations. The next thing we want to talk about are compositions. So I have f of g of x and g of f of x. And I could have f of x if I really wanted to. But these are your two main ones. Okay, so then this really means f of g of x written like that. And this is g of f of x written as such. Now again, that was out of the 2. You should have addressed that. So we want to really focus in on the domains. So the domain are the unions the domains of these are the unions of the function domains. Okay, so if we look at one here, let's say we have f of x equals 1 over x minus 1, and g of x equals 1 over x. Okay. If I find the domain of each one of these, so if we look at this one, I can't have 0 on the bottom. So that'd be negative infinity to 0 union 0 to infinity. That's this function. If I look at this function over here, 1 would make that a 0 on the bottom. So I got to get rid of that. Okay. So there are my function or my domains of those two. And if I want to look at what is f of g of x, which is f of g of x. And in this case, I'm going to take the g of x function, which is this, I'm going to plug it into the f. So I'm taking this and I'm going to plug it right here to the f. So I have 1 over x minus 1. Okay. So now I can't leave it like this, so we're going to have a common denominator in the bottom. So it'd be x over x. So I'm going to go ahead and change this 1 over 1 over 1 minus x over x. So I'll combine these now. We'll do outers over inners to divide those fractions. So I have x over 1 minus x. So that's the actual composition of the two functions. But I want to worry about the domain. Well, thinking back over here, I need the union of these two domains. Well, for both of these together, I have to get rid of 1 and 0. So when I come over here, I also have to get rid of 1 and 0. So we're going to say negative infinity to 0, union, 0 to 1, union, 1 to infinity. So I start at negative infinity, I'm going down, or I'm going right across the number line, and I'm plucking out 0 and 1 for my functions. Okay. So let's try another one here. Let's say that f of x equals 1 over x minus 2, and g of x equals radical x plus 3. Okay, we'll first find the domain of each. This one's probably easier. I can't choose 2, so negative infinity to 2, union 2 to infinity. And then we'll go to this one and say x plus 3 has to be bigger than or equal to 0. So x has to be bigger than or equal to negative 3. So that is negative 3 to infinity. And we want to find what is f of g of x. So you're taking the g function and you're putting it into f. So I have 1 over radical x plus 3 minus 2. That's what I have. Okay. Now I want to look at the domain. Okay. The domain is the union of both of these. Okay. So we've got the domain of each one of these. Okay. So now we need to figure out what they share. So we'll start with negative 3 to infinity. Now we've got to figure out, okay, negative 3 what down here would make this 0 is what I want to know. What's going to make this down here 0? Okay. So, right, because 1 plus 3 is 4. The square root of 4 is 2. 2 minus 2 is 0. So I have to take this and get rid of 1. So we're going to say negative 3 to 1, union 1 to infinity. Now, you'll say, well, how did I really get that? Okay. Well, I used the fact that this 2 I cannot choose. Okay, and because of the order I'm going here, we'll set this, the square root of x plus 3, equal to 2. Or not equal, because it can't equal 2, because it makes it a 0 right here. Okay, and we solve that. We'll square it. X plus 3 cannot equal 4, minus 3, x cannot equal 1. Okay, so that's why we got rid of 1 over here. Okay. So the domain of those compositions are a little bit tricky. You have to use the domain of this and then the domain of this, which is similar to unions. Okay. So we'll work on that a little bit more. Okay, let's say we have f of x equals x squared minus 7, g of x equals 5 minus x squared. And we're going to go a little bit easier, and we're going to say find f of g of 1, find f of g of minus 2, and let's find g of f of 3, and g of f of minus 4. Okay, so what is this telling me to do? Well, this is telling me to take 1, plug it into g, get an answer, take that answer and plug it into f. Okay, so we'll take 1 into g. So 1 squared is 1, 5 minus 1 is 4. So now we want f of 4. So 4 squared is 16. 16 minus 7 is 9. Okay, negative 2 into g, that answer into f. So negative 2 squared is 4. 5 minus 4 is 1. So now I want f of 1. 1 squared is 1, minus 7 is minus 6. 3 into f, that into g. So 3 squared is 9. 9 minus 7 is 2. So I want g of 2. Okay. And then I want 2 squared is 4. 5 minus 4 is 1. So I've got negative 4 into f. So a negative 4 squared is 16. 16 minus 7 is 9. 9 into g. 9 squared is 81. 5 minus 81 is negative 76. Okay. So that's just, some back substitution with that. We've got application problems here are great for composition functions. Okay, so let's say I want degrees Fahrenheit given Kelvin. Okay, and we know, or I can look it up, that Fahrenheit is 9/5 C plus 32, and C, or Celsius, is Kelvin minus 273.15. Okay. And I want one function that will give me degrees Fahrenheit if I know what Kelvin is. Okay. Well, it's simple. I just have to compose these two functions. I will take this function and put it into the other one. So 9/5 K minus 273.15 plus 32. I'll distribute, I'll combine like terms, and I'll get f of k equals 9/5 k minus 459.67. Okay, so we just combine them. Okay, now here's an even better problem. Okay, so let's start this. We need to know this for life and for a test or something like that, because people get this wrong all the time. Okay, let's say I work at the store at, let's say, I don't know, JCPenney, some clothing store, or Hollister, or wherever. I work at some clothing store and I get a 30% employee discount. Okay. And I've picked out this really nice jacket or overcoat that I want, and I found a coupon for 10% off. Okay. Now, most people would say that we get 40% off, so I'm only going to pay 60%. That's not how it works. The store is going to take 30% off, and then off of that, they're going to take 10%. They're not going to take 10% off the original item, or they're going to do it the other way around. It doesn't matter. So with the 30%, we're going to pay 70% of the item. Okay. Now, off of that price, we're going to pay 90%. Okay. And if I multiply those two together, I'm still only paying 63% of the original item. Okay. But I'm not paying, if it was 40%, I'd be paying 60%. That's not the case. They do these discounts one at a time. If they did them both together at the same time, then it would be 40. But they do one at a time. They do your employee discount, and then they do your coupon. All right, so we've got our suggested problems here. Let me pull them up. Okay, so here they are. So 79 looks like your challenge problem. So that's a pretty good problem. You're going to have to look up some outside things for that. If you got questions, please don't hesitate to ask. Just let me know. As always, thanks for watching. This is at THS Mr. Jones signing off.